All right, now with part 2. So we've answered the questions, and now we're actually going to start the lab. All right? So what state is this ice in? Solid, right? Solid water we call ice. Now, what do I have to do to make the ice turn into a liquid?
Melt.
I have to melt it. Well, how do I melt it?
Put it on something hot.
Put it on something hot. So, Deontay, what does that mean I'm doing with the energy if I put it on something hot? If I put it on something hot, it's going to get cold? We gotta work on your physics, man. We got to work on your physics. All right. Pay close attention because we need to make sure you get this, okay? So I am going to increase the kinetic energy. All these particles, even in this solid, are moving, right? We talked about how all atoms are moving. Guys, I want you to pay close attention to this because we will have a quiz over this, and I'm trying to help you. All right? Trying to give you a hand. Let me help you. So even these solid molecules that are frozen solid together are still moving. They're just not moving very much. So if we add some kinetic energy to it by heating it up, then we can change the state of matter. We can go from a solid to a liquid. And in order to move up, we have to do what with the energy, everybody? Add energy, right? We got to add energy to it. So it's already starting to melt for us. Good. Be patient with me. This does take a second. While I'm waiting, I'll start with our next part. So what is our next state of matter after a solid? Liquid, right? So we should see this joker turn into a liquid. Right?
Yeah.
Is it doing that? Oh, it's almost all liquid now. We've almost got enough energy added to our solid to make it a pure liquid, right? Getting there. A little bit longer. A hot plate set on high. See how long it takes. You could actually increase or decrease the amount of time it takes to freeze or thaw or melt this if you change the chemical makeup of the water. You guys ever notice, anybody here ever make ice cream? Ever make ice cream? What do you put in the ice cream besides just milk and vanilla and ice? What else? Salt. Now, did he add the salt for the flavor? No. What did they do the salt for? Salt actually, any solute like salt, actually decreases the freezing point of a liquid. So if I were to add salt to this, it would actually take more than 32 degrees Fahrenheit or 0 Celsius to freeze it. It would drop down, so it'd get colder. I've actually got a salt water ice bath behind the counter right now that I'm going to use for a special trick. Right now it's sitting at about 15 degrees Celsius below 0. It's pretty cold. It's about as cold as most of your walk-in freezers are. It's pretty cold. So now we have completely changed our solid into a liquid. So are these atoms still kind of bonded together?
Not really. It's all over the place because it melted. It's water.
Well, they are free to move around, but are they free to go any direction they want?
Oh,
No, they're not escaping, are they? They're still kind of bonded. They're just very loosely bonded. That allows water to flow and move, but stay together. So now what we're going to do is we're going to add even more kinetic energy. What's it going to do now? If I put it on the hot plate and I add more kinetic energy to it, it's going to boil, right? It takes just a second, so we'll give it a bit. And while it's doing that, we're going to talk about another type of vaporization. Can anyone remember what type of vaporization we haven't talked about yet? We did boiling. There's only one other. If you leave water outside on a hot day, evaporation. Has anybody here actually sat and watched something evaporate?
No.
Man, I'm sorry. We'll find you. There's great books. There's movies. There's other things to do besides watch things vaporize. Trust me. But luckily, I can speed that up for you. What is this?
Acetone.
Acetone. What is it?
Well, it's like acid.
It's kind of acidic, yeah. This is a solvent. It's used in a lot of chemistry labs. Any of y'all girls or guys go out there and get your nails done? Yeah. You ever notice they stick your hands in some of that funny smelling liquid? It's kind of cold and tingles. That's what this is.
What you mean, God?
Hey, man, it's a new world. Whatever you do on your time is your business. I don't judge. Okay? So what I'm going to do is I'm going to pour just a little bit of this onto my counter, like that. Now, if you watch, if I spread it out, look at that. You can watch it evaporate right there before your eyes. See it? It evaporates really quickly, right? Now, what's happening is at the surface of that liquid, the air is warmer than the acetone. The air has space for these molecules to escape. And this substance here, this acetone, wants to become a vapor. Right? Naturally, it wants to become a vapor. If I open this up and leave it out, it will just evaporate entirely. It'll take a little while, but it will. And you can see we're already completely evaporated from the table. It doesn't take very long. Now, for you ladies who get your nails done, what does it feel like when you stick your hand inside that liquid? It gets cold, right? Where does that cold come from? You ever wonder why it's cold? Because this is room temperature right now. This has been sitting in this lab right here behind the counter for like 2 days. Why is it cold? Well, it's a physical thing, right? So let's think about this. If it's going from a liquid to a gas, what's happening with the energy? Is energy being absorbed or is it being released?
It's absorbed.
It's absorbed because we're going from a liquid to a gas. We're going up. So that absorption is why you're feeling cold. When you put your hand in that liquid and it feels cold, that's because that liquid is evaporating on your skin. And when it evaporates, it pulls heat out of your skin. And you can feel that. Does anyone want to try?
Yep.
Yeah? So I'm going to keep the camera facing this way. Whoever wants to, you, come over here and just dip your hand just a little bit. Smear it around and tell me what you think about the sensation. How does it feel? It feels cold, doesn't it? It's nail polish remover. That's pretty much all it is. Right? You can feel the cold though, can't you? All right. Thank you. Thank you. All right. Let's check up on our next state. Still waiting. Still waiting. So make sure. Do me a favor, everybody. Let's write this down in your notes. This is important. So I want you to write the word vaporization. Vaporization. Who's got my water on?
Me.
Oh, okay, you're good. Here, put some of this on your hand. That stuff will dry you out. Oh, threw it short. Threw it short. Here, paper towel. Good catch. Okay, so we have vaporization. And underneath vaporization, there are 2 terms we're going to use. Does anyone remember them? Boiling and evaporization. Evaporation. I always want to say evaporization. It's evaporation, not evaporization. Boiling, where does boiling occur at the liquid? Does it occur at the surface of the liquid or does it occur inside the liquid? Inside. So boiling occurs inside the liquid. And what do we call the one that occurs at the surface? Evaporation. Evaporation. And both of these, hey guys, both of these are forms of what? Going from a liquid to a gas. Umbrella term. Starts with a V. Vaporization. Both of these are forms of vaporization. Well, this water is taking its sweet time. Come on now. We'll give it just a little bit longer. So I'm increasing the kinetic energy. I'm turning that water into a gas. And here, hopefully soon, we should have some steam, some water vapor coming out of the can. When we do and it starts to boil, then we can do our next trick. Okay? Now, while we're waiting, let me add some more questions. See how you guys are doing. What subatomic particle determines what element a substance is and where it's found on the periodic table? Deontay, this is the last time I'm going to ask you, sir. The atomic number, that tells you where it is, but what determines the atomic number? Because that determines where it is.
How many protons?
How many protons? Right, that's important. Okay. Now, which do you think has more kinetic energy? A liquid or a plasma? Plasma. All right, good. Plasma. 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 Oh, we're getting close, guys. We got bubbles. We got bubbles. We're getting there. Just a little bit longer. We're almost there. Okay. This should be a review. We did this a little bit earlier, but just to add some extra review. What state of matter has no volume or shape? Gas. Which one has a definite shape and volume?
Solid.
Solids. There we go. Which one is an ionized gas? Miles? Plasma. And which one has a definite volume but not a definite shape? Liquids. All right. What do we call the process of going from a solid to a liquid?
Melting.
Melting. What do we call from liquid to solid? Freezing. What about going from a liquid to a gas?
Vaporization.
Vaporization. Nailed it. That's the word I want you to think of. There are two types of vaporization, right? What about going from a solid, skipping liquid, and going straight to a gas? Sublimation. One of my favorite changes of state. What about going from a gas directly to a solid?
Deposition.
Deposition. Good job, Chloe. Okay. Whenever a gas is condensed into a liquid, is energy absorbed or released? Released. Nailed it. And what about going from a solid to a liquid?
Absorbed.
Absorbed. Nailed it. I think you guys are going to do really well on this quiz. Oh, we got movement. We got movement. Okay. Now, you guys probably can't see the steam coming off of this thing unless I do this. Can y'all see it now? See the steam? Yeah. Yeah, you see it? Okay. So what's happened now is I've added enough kinetic energy that the bonds holding those water molecules close together have broken, and the water molecules are allowed to flow around and move a lot more. They get moving so much that sooner or later some of them get kicked out of the liquid, and they start to float up into the air, Mr. Pope, and they become water vapor, which is what you're seeing. Now, I have a question for you. I want you to think, what do you think is going to happen to the volume of that water if it's condensed?
It's going to turn to that. It's going to freeze or something like that.
Well, let's think about it. Gases don't have a set volume, right? They can expand or contract, right? So what I'm about to do is cool this gas down quickly and condense it. What do you think is going to happen to the volume of that material?
It's going to go down. It's going to get mad.
It's going to go down really fast. So let's see what happens if I take this can full of hot water vapor and put it in here. I'm going to seal the opening with the liquid. Y'all ready? Watch real close. Hopefully this works. I had it one time, it didn't work because I didn't get it hot enough. But I think that's hot enough. Here we go. Woo! Did y'all see that?
Yeah.
So what just happened
It blew up.
is, well, it imploded instead of exploded. Imploded. So that hot water vapor that was occupying the can, the hot water vapor pushed all the air out of the can. And so the can was full of hot water vapor. And when I flipped it over upside down, that vapor condensed. But since the opening to the can is underwater, when it condensed, it decreased in volume. And it sealed. So it created a vacuum inside the can, and the can has no option other than to get crushed. All right? If we have enough time, I'll do another one of these later on. That scared you? A lot of people like that one. Okay. So now I'm going to pause so I can move over here. I'll be right back.